in this section, we're still going to be dealing with segments, and we're going to start breaking these segments apart, and we're going to figure out how to find the middle of a segment and how to find the length of a segment that's not vertical or horizontal, and it's on the coordinate plane. So first thing I need to do is I need to do some definitions. These are your 1.3 vocab terms. A midpoint needs to be in your vocab notebook. A midpoint divides a segment into two congruent segments. Okay? A midpoint divides a segment into two congruent segments. A segment bisector is a point, line, ray, or plane that intersects a segment at its midpoint. So a segment bisector goes through the midpoint of a segment. Okay. So the next thing we're going to talk about is we're going to talk about the midpoint formula and the distance formula. Both the midpoint formula and distance formula go into your postulates and theorems notebook. They are in your textbook as a key concept. So make sure the table of contents information that I gave you for your postulates and theorems notebook, that you write the distance formula and midpoint formula on the correct pages in your postulate and theorem notebook. They will be going towards the back of your postulate and theorems notebook. Okay? So first thing we're going to do is we're going to talk about the midpoint formula. Okay? Unlike postulates and theorems, you do not have to copy it word for word out of the textbook. You're going to need the formula and maybe the pictures that go along with it. So the midpoint formula. Okay, the midpoint finds us the middle of the segment. Okay, and what we're going to do to find the middle of the segment is we want to find the middle of each type of coordinate. For example, if I have two random points, first point has the coordinate x1, y1, and the second point has the coordinates x2, y2. If I want to find the middle of that, the middle point is going to be halfway over and halfway up. Well, halfway over is these two numbers added together, divided by 2. Halfway up are the y coordinates added together, divided by 2. So to find the midpoint, you find the average of your x coordinates and the average of your y coordinates. If you're using a three-dimensional system in some of your future classes, the z coordinates midpoint would be add the z's up and divide by 2. So we're going to find the middle of each type of coordinate, and that will be our midpoint. Okay. So m is equal to x1 plus x2 over 2 and y1 plus y2 over 2. That's the coordinates of my midpoint. So the midpoint is that coordinate. The next formula we're going to talk about is the distance formula. And the reason why we covered the Pythagorean theorem in class before this lecture is because we're going to need the Pythagorean theorem to come up with this formula. And once we come up with the formula, I'm going to write it in a different way, and I'm going to give you some words on the way I want you to remember the formula. Once that's done, we're going to go through some examples. So the distance formula, again, goes in your postulates and theorems notebook in the correct page. Okay, what we're going to do here is we're going to come up with it. Okay, and we're going to need the Pythagorean theorem to prove it. That's why we came up with a proof of the Pythagorean theorem. So what I'm going to do is I'm going to take 2 points on my coordinate plane. Any 2 points, again, I'm going to call them x1 and y1, and x2, comma y2. What I'm going to do from these points is I'm going to go horizontally through this point and vertically through this point, and I'm going to write down the point where they intersect. Well, that point where they intersect has the same y coordinate, so that would be y1. So same y coordinate as this one, because it's the same height, and it has the same x coordinate as this one, which would be x2. What I am trying to find out is I'm trying to find out this distance between A and B. I want to find that length. Well, you should note that if I have a horizontal line intersecting a vertical line, I have a right triangle. And that right triangle, I can use the Pythagorean theorem because this length is the length of the hypotenuse. So what I'm going to do is I'm going to call this segment C. We'll call this one A, and we'll call this one B. And I know that using the Pythagorean theorem, that C squared is equal to A squared plus B squared. Let me call that point C. So I know that the length of AB squared is the length of BC squared plus the length of AC squared. Now all that is substituting what those things mean. Well, we know the ruler postulate is usable on horizontal and vertical lines. And we know that the length of a horizontal segment or a vertical segment is the absolute value of the difference of the coordinates of the endpoints. Still need these squares. And I need the absolute values of the coordinates of the difference of the endpoints. So endpoint here would be x2 and x1. So x2 minus x1. Endpoints here are y2 and y1. Then I want to get rid of this because I don't want what AB squared is. I just want AB, so I'm going to take the square root. And I want the principal square root, so I just need the positive one. And if I take something and square it, whether it's positive or negative doesn't matter because I'm still going to end up with a positive. So these absolute values can go away and become parentheses. y2 minus y1 squared. That is the distance formula. I'm going to call this lowercase d for distance. So distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This is what's in your textbook. Okay? This is how far our x moves. This is how far our y moves. So here's the way I want you to remember the distance formula. The distance of a diagonal segment, okay, this is the distance of a diagonal segment, is equal to the change in x squared plus the change in y squared. Make sure that this is written in your postulates and theorems notebook on the correct page. Words, it is the square root of the sum of these squares. So if I want you to find the length of a segment or the distance between 2 points on a coordinate plane, you're going to take the square root of the sum of the squares, and the squares things are the change in x's and the change in y's. Okay? This is the way I want you to remember it. Okay? This gets messy, students forget it, and they freak out. If you just remember the distance between 2 points is the square root of the sum of the squares, you will always get it right. Okay? Square root of the sum of the squares. And the squares are how far my x's are apart and how far my y's are apart. So we're going to use all of this information to do examples. Make sure these examples are in your notes because they will be graded. And they will also help you with the assigned homework. and classwork that you will be doing. So the first example is I have the following points. I want, if I'm given, point C has the coordinates of 3, 5, and point D has the coordinates of 7, 7. I want to find the midpoint and the distance. Okay. If I'm given two endpoints, what I always do is I always write the points vertically above each other, and I do the work like this. So the midpoint is I add up these two numbers, divide by 2. I add up these two numbers and divide by 2. 10 over 2 is 5. 12 over 2 is 6. That would be the midpoint. Now the distance is equal to the square root of the sum of the squares. I always write my framework first. And how far is it apart between 3 and 7? 4. How far is it apart between 7 and 5? 2. So that's going to be the square root of 16 plus 4, which is square root of 20. And you should know that that's the square root of 4 times the square root of 5, which is 2 root 5. Okay, in the geometry class, I'm primarily concerned that you know the geometric setup. So getting me this part right here is the geometry. The rest of it is simplification. This right here gets you a passing grade in the geometry class. The rest of it gets you the higher letter grades, being able to do the rest of the arithmetic associated with it to give me the fully exact correct answer. So passing grade right here is understanding this and this. Passing grade. Those two setup things, this part right here would be the final answers is for full credit. The other way they can tell us is, for example, I have segment RS with the following information, that point R is at 5, 1, and I know that the midpoint of RS is at 1, 4. I want to find the coordinates of point S and the length of RS. Okay? So here's what I'm going to do, is I'm going to put R and put its coordinates. I'm going to put S, well, I'm going to put the midpoint here in the middle, put its coordinates, and then I'm going to put S, and that's what I want to find. I am going to show you how to do it without going back and plugging numbers into a formula. Then I'm going to show you how to use the formula to come up with the other endpoint ones. Okay? To me, this is the easiest way to do it. Going from one end to the middle, I subtracted 4. So to go to the middle of the other end, I have to subtract 4 more, which would be negative 3. To go from one end to the middle, I added 3. So to go from the middle to the other end, I have to add 3 more, which would be 7. Here's the way that you could have came up with it. We know that the x-coordinate of the midpoint is equal to the first x-coordinate plus the second x-coordinate over 2. Substitute the information that you know. X-coordinate of the midpoint is 1. X-coordinate of the first point is 5. Plus the x I don't know, all over 2. Now I want to solve this. Multiply both sides by 2. And I get 2 equals 5 plus x sub 2. Subtract the 5 from both sides, and I get x sub 2 equals negative 3. Notice, this is a lot of work. If you do the setup the way I did it, how far did I go from 5 to 1 is down 4. That means I have to go down 4 more. I went up 3, which means I have to go up 3 more. Okay, that will save you time in the long run, and that's the way I recommend you do it. Now, I've only answered half of the problem. I've given you the coordinates of the other endpoint. What I need to do now is I need to find the length of segment RS. Well, the length of RS is equal to the square root of the sum of the squares. Again, I write down the framework before I put any numbers in. Now I kind of want to hide the midpoint, so I can think about this. How far are these two numbers apart? Between 5 and -3 are 8 units. Between 1 and 7 is 6 units. That's the C answer right there. Now, I get the square root of 64 plus 36, which is the square root of 100. And because it's a distance, I only need the principal root. That's why I didn't put plus or minus. And that is equal to 10 units of length. So I've given you examples of me giving you 2 endpoints to find the middle in a distance, or giving you an endpoint in the middle to find the other endpoint in a distance. Make sure you can do both types of problems, and make sure that you have the examples written down so that when I check your notes, you can get full credit.